we welcome Elisabeth, and dependent types are everywhere. Hello and
Thank
welcome,
you.
Elisabeth. Yeah, welcome.
Thank you. Hi, everyone. And thank you to Func Prog for having me. Whenever someone is talking about functional programming, I want to join and talk about it because what else is as fun to talk about? So, my talk today, I named dependent types are everywhere. And that is the sort of main point that I hope to get across today. And the subtitle is with application to questionnaires, which seems very random that these two things go together. But I will give you the backstory for why we are here today listening to this talk. So, I work as a software developer at an insurance company, a Norwegian insurance company called Frende, and I have a PhD in dependent type theory from before that. So I was talking to my colleague one day, and he had been thinking about questionnaires because there's a lot of questionnaires at an insurance company. For instance, if you crashed your car and you need your insurance to cover it, we need information about the accident. And he was thinking, talking to me about the questionnaires that we have, and you know, all of the questionnaire code is like super hard to read. It's spaghetti code, like it's hard to follow. Why is it so hard to write a good questionnaire? Like it seems very simple, but I don't know if anyone listening has ever tried to write a questionnaire, not just one questionnaire, but like a framework for creating questionnaires. But you think it sounds easy, but then you sit down and you try to set it up and you're like, wait a minute, how do I actually do this? And he was talking to me. Of course, I have a PhD in dependent type theory, which means I got a hammer. So that means that the problem he was asking about was a nail. I mean, it took a little while, but then I came back to him and said, yeah, you know what? This is difficult because it's actually dependently typed, but we're trying to express it in a language that doesn't have dependent types. So I'm going to try to convince you today that it's not just that I have a hammer, but this is actually a nail. So first of all, let's talk about what dependent types are. So Christopher mentioned it already, but it's probably a not well-known concept for most people. It's kind of niche. So we have in our ordinary functional programming languages some sort of dependency. So types that depend on something. So for instance, list is a type that depends on another type. So you need to say the type of elements, and then you get the type of lists with that type of elements. And depending on which type you give it as elements, you get a different type, right? So for instance, I have my list here, which is a list of integers, and it's just 1, 2, 3. But I could also have a list of bool, a list of string, and those are all different data types. And they sort of you can think of it as a function that list as a function that takes a data type as an input and then produces a new data type. And this is all well and good. We're all familiar with this. But here's a common problem that we have with lists in our usual languages. Let's say I want to grab an element from a certain index at a list, then I give it an int. But if I as a programmer need to make sure it's actually a valid index, otherwise I get an exception. I get a runtime exception that the list index was out of bounds. But with dependent types, we can actually define types that depend on values from other types, not just on types. List depends on a type. You give it a type, int, and it produces type. Okay, but with dependent types, that means that you're giving it a value, like an int or a list in my case that I will show, and that gives you a new type. So for instance, that means that we can define the type of indices in a list. So I can define a type And this code is code that actually compiles. This is a language called Idris. It's Idris 2. There's also Idris 1. And here I define a type that takes as input a list, so a value, and it produces a type. And the type it produces is what's called in this language fin of the length of the list. And fin, if you're a mathematician, this is the type, the finite set or the finite type with a certain number of elements. And the number of elements is the length of the list. So we're programmers, we start counting at 0. That means this type contains the numbers 0, 1, 2, and so on until the length of the list -1. So here I give an actual list as input, and it produces a type that contains as many numbers as my list is long. So this type depends on the list and not on like a type or it's not a static type like you would use for getting an element at an index. Usually you would use an int. So for instance, if I plug in my list that I defined there, I get that index of my list is the type 0, 1, 2 that contains two elements 0, 1, and 2. And this means that we can get an element from a list safely, and we cannot get an index out of bounds error. It's safe compile time. So we can define a safe get, which takes a list and it takes an index of that list. And here I want you to recognize that this index type takes the list as an argument. And then we get the element at that index. And this is safe. This is not going to give you any runtime errors because you can the indices like that you have available depend on the list. I'm not going to go into the implementation here. It's defined in the standard library of Idris. But the point is, you can have types that vary with an argument. So this gives a lot of expressivity in the type system. So it's like turning, I mean, Christopher talked about type systems and that they're more expressive. And this is like turning expressiveness up to max. You can express basically anything you want in the type system, so in the types, which then gives you like a lot of assurances compile time, because you can express things in the types, which the compiler can then verify and check for you. As opposed to not having dependent types, then you have to do more runtime verification, as for instance, this index out of bounds problem with lists. So what does this all have to do with questionnaires? As I sort of hinted, it turns out that questionnaires are actually inherently dependently typed. So I'm going to try to explain that now. So this is a picture I made of a questionnaire, which really shows, hopefully, that a questionnaire is a graph, basically. So you have the different questions, and depending on what you answer, you might go to a different question. So this would be a small example of a questionnaire where an insurance holder has crashed a car, and we need some information. First question, did you drive the car or did someone else drive? And they can answer yes or no. I drove, I didn't drive. If they drove, then we have all of their contact information, so we don't need to ask for that, and we go directly to the last question. Where did the accident happen? Because we need to know, did it happen inside or outside Norway? And then we're done. If they said, I didn't drive, then we need some information about the driver. So we ask, what's the name? They give the name, what's their phone number? They give the phone number, and then we get to the location question. And then we're done. Okay, so a questionnaire is a graph. That's fine. Now let's think about what is the type of valid answers, like valid ways to go through this graph? Well, some examples, like you could answer yes to the first question, I drove, it happened within Norway. You could answer maybe no, I didn't drive, hatt if not drove. This is one of our test names. And this is a phone number and it happened outside Norway. No, someone else drove, phone number happened within Norway, and so on. What I want to point out here is that this type of valid answers depends on the graph. So it's not, you can't define like a type of valid answers for a questionnaire statically for all questionnaires. It depends on the specific questionnaire you're looking at, and it is the type of paths that you can take through the graph. So that is inherently dependently typed. You're taking paths in a graph, and the type of paths depends on the graph, the actual graph. So that's a dependent type, and there's actually some more dependencies hiding here. So let's look at the first question again. And they answer yes or no, basically a bool. And depending on the answer, we go to different questions. So we have a function that takes a bool and returns what's the next question to go to. But over here, instead, they answer with a string. What's the name of the driver? And then given the string as the input, we say what's the next question. In this case, we go to the same question regardless, but we could have gone to different questions here, depending on what the answer was. And these two functions have different types as for the answers of the question. So we have bool and we have string. And this is a dependently typed thing. If you don't have dependent types, you're going to have to, when you say what a questionnaire is, you're going to have to somehow say once and for all what this type to the left of the arrow should be. Conceptually, maybe you don't actually write it as a function, but you need to say what kind of answer goes to what question. And this type cannot change depending on where you are in your questionnaire in a non-dependently typed language. But in a dependently typed language, this type, the bool and the string, can vary depending on where you're at. So that's very nice. And now I have implemented a framework for creating questionnaires in Idris, and the language I showed previously. And I have also implemented this specific example in my framework. And I thought that for people who are new to dependent types, it would be the most interesting thing would be to see how does such code actually look like? Because that's what I would be wondering if I hadn't done this before. Okay, this sounds good, but like, how does such code look like? Can I read it? Like, is it insane? Yeah, it's not that insane. So I'm gonna show you a couple of snippets of the actual code that does my example questionnaire here, and then I'm gonna demo and show you that this code actually runs. So this is, as I said, Idris 2. It's a dependently typed functional programming language that I used to implement this. So we're jumping into the deep end immediately. First, let's talk about the data type of questionnaires. So basically, this is the type of graphs, but with the data that we need to create specifically a questionnaire. And we define it inductively. So we're saying, okay, if you think of it in terms of graphs and nodes and leaf nodes, we're basically saying, okay, so a graph could be it could be a leaf node, and then we just need whatever data we want at the leaf node, which in my case, it's going to be, I want to have a full set of, I have to find a data type for the set of valid answers that I want out of this questionnaire when the user is done. And I need that. And then I also have some other data that I need for creating a model view update a model view update front end of this questionnaire. So, but that's a leaf node. As soon as we have that data, okay, we have a graph. It's a simple graph because it's just a leaf node, but it's a graph nonetheless. The other case is when you have a non-leaf node, and then I say that I want some data. Again, this data contains stuff I need for creating a model view update front end of this, but also, crucially, this data, it's a record type, and it contains the, which I call answer type in this record, which is the type that the answer to this question has. So for the first question, that would be bool. For the name question, that would be string. And that is stored in here. And you usually can't, I don't know if you can, in functional programming languages without dependent types, if there are languages that allow you to have types as variables. But you can in Idris, so you can have it in the record. And then I say that, okay, I need also a function that given an answer, so an element of the answer type, you need to say which question to go to next. So a function from the answer type to the type of questionnaires. So you're pointing out another graph, basically. And this could be a leaf node, but it could also be another non-leaf node. And this is where we have this dependent type. So the type to the left of the arrow here depends on the data that you had previously, and it varies. And then that gives you a non-leaf node. So concretely, in my specific example, the first question is the question, did you drive? And it takes the next question function, takes a bool, and returns which question I should go to next. If you answer true, I drove. We go immediately to the location question, and we know that the person who drove is the insurance holder. If it's false, then we go on to the name question. So we can actually use the type here. We can pattern match on the elements of the type here to go to the correct question. For the name question, instead we take a name and say what question to go to. Name here is actually not just a string, because we're in a dependently typed language, and that means that we can actually put constraints on our types on the type. So in this case, name is an alias for a non-empty string. So I have the constraint in the type that it should be non-empty. And here I say that whatever name you get, we go to the phone number question. And again, I want to point out that the type to the left of the arrow here varies depending on which question we're at. And we can do this because we have dependent types. Some more fun stuff from the code. I defined the type of phone numbers with constraints so that we can only have valid Norwegian phone numbers. So a phone number consists of digits in a Norwegian number without the country code. It's 8 digits. And a digit, of course, it's not just any character. It's actually a number from 0 to 9. So it's an element of fin 10. If you recall, that's 0 to 10 minus 1. So 0 to 9. So we need digits, that's those. And then I also have a type that I call isValid_number, which takes a 8-long vector of digits and says that it's a valid number, which means for a Norwegian number that it starts either with 4 or with 9. And here I want to point out the head of number equals 4 and the head of number equals 9. These are now types. Usually one uses like the double equals sign in most languages, which gives you a bool. But that's a value. And this function is returning a type. So these two things, head of number equals 4 and head of number equals 9, are actually types. And the way you can think about these types is that they could be empty if if head of number is equal to 3 or something. It's not actually equal to 4 or 9. Then both of these types will be empty. But if the head of number equals 4, if it's 4, then the left type, the head of number equals 4 type, will contain an element, which is basically a proof that the head of number equals 4. This is a lot to wrap one's head around, and there's actually an entire branch of dependent type theory called homotopy type theory that sort of builds out from thinking about this type. So if you're confused, don't worry, like it's a whole field of research. But you can do this in the type system, so you can put this constraint in the type system, which means that you have this constraint compile time. So then I define my mobile phone number type, and I say it's a vector of 8 digits, and that this vector should be a valid number, meaning the head should be either 4 or 9. And this is the Idris, these two asterisks. That's just the Idris syntax for a tuple, where the second, the type of the second value can depend on the first value. In this case, it does depend on the first value. So my mobile phone number, I know is going to be an 8-long vector of digits, and the first is either 4 or 9. And this is compile time. So I don't have to, as a programmer, just remember every time I create a mobile phone number. If you had like just I don't know, a list of int or something in a non-dependently typed language as your type of phone numbers, then you would have to always remember whenever you're creating a phone number to check that it's a valid number like this. And I mean, you can make it private and have only be able to create it through something that checks this, which is works fine, but it's possible to represent phone numbers in your type that are invalid. Here, it's impossible to represent them in the type. This type only contains valid numbers. So that's kind of cool. I still, of course, when the user gives their number, it's going to be as a string. So I still need to try to parse this string into a valid phone number. And if that parsing could fail, it could be invalid. But then I need to do something to get the user to try again or fail in some way. But the thing is, I cannot forget it. I have to do it. My code won't compile unless I have implemented some way to get a valid phone number from user input, usually by trying until I get something valid. And then finally, I want to point out something that I realized, another dependency that I realized when I was going to implement this with a model view update web frontend. So I was going to do a model view update frontend with Idris, and Idris compiles to JavaScript. So there are libraries for model view update that compiles to JavaScript. It's very nice. And then I came there and I was like, what should the event type be? What should the state type be? And I realized that the event type is actually a dependent type. It should depend on the state type, right? So I don't know how many of you have used model view update before, but you have a state and you have a type of events, and usually they're separate, completely separate. So you have your type of states, your type of events, and then you need to have an update function that takes a state and an event and gives you a new state, and you have a view function. The thing is, when these are separate, then you need to handle every combination of state and event in your update and display function. But if you think about it, in most cases, your event type, like not all events happen at every state. They differ. So for instance, in my questionnaire, at the first question, I have an event for the user when they answer yes, I draw, and an event when they answer no. But on the second question, I just have a submit button and a text field for writing the name, and those are different events. And it doesn't make sense to have a yes/no event at the name input question. And similarly, it doesn't make sense to have like a text input event at the first question that's just yes or no. So the event type should depend on the state type. It should change depending on what the state is. So, of course, I had to fix this. So I took the library, the Idris DOM MVC library, it's called, and I forked it and I changed it so that the event type depends on the state type. And then I implemented using that. So here I have implemented the event. This is the event type for the for the thing that runs a specific questionnaire. So it's not the specific questionnaire of my example, but this is a general MVC that runs the whole thing. And this is the event type. So first in this library, we have an init event that is run the first thing that happens. So we just need that, but it's not interesting. It doesn't contain anything. So it's just the unit. And then I say, okay, when we're at the last question, so the leaf at the end, the leaf node, there are no events there. If this was an actual questionnaire we were using, we would probably submit the answers somewhere. But in this case, I haven't implemented anything like that, so there's nothing there. And then here, this is the interesting event type. So when you're at a non-leaf node, so a question that continues somewhere, then either it could be like a local event. So every question has its own event type and its own update and display that does stuff when you're not finished with an answer, but the user is interacting with the question, but staying within that question. So it could be either an event of that question, or we could get an answer to that question, in which case we will be moving on to the next question. Okay, so the event type here depends on the state, which means that, again, I get more guarantees compile time. I know that any combination of state and event will only be a combination that actually will happen and that actually makes sense. So a lot of talking, a lot of showing code. Does this actually work? It does, and I will demonstrate that now. So here is the questionnaire for the graph I showed. So it starts with, did you drive the car? Yes, I did. Where did it happen? Let's say within Norway. And then here on the last question, I'm just displaying the data that we would then be sending off somewhere. Let's say, okay, I did not drive the car. Nope. What's my name? Or the name of the driver. Let's just say my name here. And I submit, and then I get to the phone number question. And does this work? Nope. I have to give a valid phone number. Okay, let's try 8 digits. And remove that one. 8 digits. Nope, doesn't work because the first one isn't 4 or 9. So let's try with 9. Yay. And then, yeah, let's say it happened outside Norway. And then this is the thing I end up with. So all of my talk actually works in a questionnaire. And this is interesting. My keynote stopped working. There we go. Okay. And let's keep going. So, takeaway. What is my point with all of this? Well, hopefully, maybe, I convinced you that dependent types are everywhere. So what I mean by that is like if you think about the abstract structure, don't think about like how should I write this in a programming language, but like the data structure abstractly. There are a lot of structures that are actually dependently typed, where the type should change depending on the value. But of course, that's not how we live in our everyday life. We live with programming languages without dependent types, which is totally fine and like useful and works in a lot of cases. But the thing that happens then, if you have a structure such as a questionnaire that is actually dependently typed, like abstractly, then when you're implementing it in a language that doesn't have dependent types, you're sort of translating a dependently typed structure into trying to express a dependently typed structure in a language that doesn't have dependent types, which you can do, but it puts more on the programmer that you need to verify and validate stuff runtime, and you're not going to be able to represent the structure in your type system completely. So with dependent types, the languages which have dependent types are extremely expressive. You can express like anything you want basically in the types. But of course, the downside is it becomes more complex. The type checking, the compiling is more complex. So it's like you need to get used to this way of programming, and you can get more like difficult to understand errors and unification issues and stuff like that. So, I mean, I have a PhD in dependent type theory, but I wouldn't say dependent types is the end all be all and we should be using it all the time for everything. But it gives more security assurances compile time. So to me, it makes sense that we could use dependent types for very security critical parts of software, not even maybe the whole software, but like the most secure critical parts of software. And then we could use non-dependent types for other stuff. And dependent types are also used for verifying mathematical theorems. And I didn't talk at all about this today, but that's what I did my whole PhD. But because you can express anything in your type system, you can actually express mathematical theorems in your types. And that's a whole other area, but it's super fun. And if you're a mathematician, I definitely recommend you trying to prove something in a proof assistant, which is a proof assistant is the dependently typed functional programming language, basically. And it's coming soon to a Haskell near you. Dependent types are on their way into Haskell. It's a company called Seroquel, and they claim that they're adding dependent types to the GHC compiler, but they have been working on it for several years now. I don't know exactly when they started, and it might take several more years before they're done because the GHC compiler is super complex. We have all of these language extensions. So retrofitting dependent types on top of that becomes very complex. So it can take a while, but it's on its way. If you want to try it yourself today, I would recommend doing that if you think this sounds interesting. Then you could use the language I used called Idris 2. I would say that this is the most the dependently typed language that is most oriented towards writing executables, basically. Which might sound weird. What do you do if you don't write executables? But what you do if you don't write executables is that you use it as a proof assistant, and you verify your mathematical theorems by just type checking your code. Then you also have a popular one called Lean 4. That's the most recent rendition. This one is, I would say, more geared towards being a proof assistant, but it can do executables. But if you want to try formalization of mathematical theorems, I would probably start with Lean 4. It has a good a large library of mathematical proofs. But you can also do executables with it, and it's very easy to get started with because it's developed by Microsoft, so it has support for VS Code. So you just install the extension in VS Code, and then bam, you're good to go. So that's nice. You can also try Agda. Agda is like Idris, very Haskell-like and has dependent types, but it also leans more, I would say, towards being a proof assistant. But you can write executables with it. And then we also have Rock. This recently changed name. The new name of this language is called Rock, and it's also, I would say, more geared towards being a proof assistant, but you can write executables with it. Yeah, I think that's it for me. Thank you so much for listening.
Thank you very much, Elisabeth. Thank you. I will start with questions immediately from the chat. Is the phone number validation at runtime the same as at compile time? That is it using the type definition at runtime?
So the validation, I have written a function that tries to validate a string into a phone number, and it cannot produce a value unless it's a valid value. So, I mean, it checks that, first of all, it checks that it's an 8-long string of, well, all the characters are digits, and then it checks that the first digit is 4 or 9. So, yeah, I don't know exactly. I mean, it's checking this thing runtime, but and it cannot produce anything that would be invalid in the type.
Thank you. Next question. Is this example available somewhere, like on GitHub, your personal blog?
Yeah, so it's available on my GitHub. I do believe that the repository is public, but I haven't posted the link anywhere, but I can do that. It's very much a work in progress though, so just beware. And also for this to compile, you need to use my fork of the DOM MVC library where I changed the event type to be dependent. But I can post a link to this GitHub. It's on my GitHub.
Yeah, please do, and we'll post also the link below in the comments or in the description later here in YouTube also, so people can find it afterwards. How come you got into doing a PhD in dependent types? This seems like an odd thing.
That's kind of a niche.
Yes.
Yeah. So my background is in abstract mathematics. I did a master's in mathematics, and I liked the abstract part of mathematics. And then I was doing it at Stockholm University. And there's a lot of dependent type theorists at Stockholm University. So I didn't know what type theory was, but I just sort of heard I don't know, by osmosis, I realized that you could use, with type theory, you could use computers to verify your mathematical proofs. And I always loved the programming courses that I took. So I was like, oh, yes, this is like the best thing of two worlds. And then when it came time to decide the project for my master's thesis, I was like, let's do type theory, although I knew nothing about it, but it just sounded fun. And then I learned dependent type theory from there for my master's thesis. And then when I was done with my master's, there was this PhD in dependent type theory, that PhD position that showed up here in Bergen. And I was like, yeah, I want to keep doing this for 4 more years. So yeah.
Interesting. What are you doing today? Are you working with Idris or are you working with something else?
Yeah, so I'm a software developer at an insurance company, and I don't get to work with dependent types, but I get to work with functional programming. So I do F#.
Nice.
Yeah, I would love to do Haskell, but I mean, F# is better than C#.
Yes. Yes. I usually give everyone the same advice. If you want to work with Haskell, you should start your own startup that uses Haskell. That's the best way to work with Haskell. Yeah. Thank you again. Thank you very much, Elisabeth. Yeah.
Thank you.
Yes. And with that, thank you everyone for watching tonight, and thanks for all the nice sharing in the chat and all the nice questions. Please do remember to follow us on YouTube, check us out on Meetup, and also check out the new podcast we're doing. And if you want some specific people to come on, either to the Meetup or to the podcast, please reach out to us and ping us, or use the chat in Discord to suggest people to come on, and we'll try to reach out to them and see if they want to come on and either present or partake in the podcast. With that, thank you everyone again, and have a nice evening, day, morning, lunch, wherever you are in the world. Bye.